Okay, good evening, everyone, and thanks for staying back all the day. And in this short talk, I will briefly give some feel for the kind of work activities that are involved, especially in Indian participation with the SKA in producing the RF and digital hardware packages. This work involves, a large number of members from the different institutes, especially Raman Institute and NCRA and other Indian SKA India members and their feedback and their involvement, which will be continuously be supporting this activity. So it sort of encompasses many different areas, and I'm going to give a feel for what these work packages mean to us when we actually want to implement them in producing these hardware pieces. So in the previous talk in the morning, actually, I have mentioned the two hardware packages. One is the RF hardware connected with the SKA mid telescope, which is the band 1 feed and associated electronics production with the help of Indian industry and guidance from Indian members from the Indian SKA India institutions. Similarly, the digital hardware, which is the tile processing module, the production of it also involves Indian industry and the institutional members from the SK India institutions. We do have niche expertise on these areas from the members who are already part of the SK India institutions. So I'm going to quickly give a feel for the RF hardware, which consists of LNAs and RF electronics, mechanical structures, and so on. As I run through this, I want to emphasize the fact that SKA has its own timeline for the mid-frequency telescope. As you could see, the year is 2021 to 2027. There is a antenna rollout plan starting from 4 dishes in 2024 all the way to the entire dishes, all the 190 odd antennas deployed and operational in 2027. It's a long plan. However, it is not going to be very relaxing. Large amount of things will have to come in right time, and so that the antenna integration happens, verification happens, and they get commissioned in the site. So here is a preliminary plan looking at the feed RF module related production and integration work. We do see there are two different kind of industries involved, and the one in green possibly may even happen elsewhere, and the one in the blue in the top may happen completely in India inside uh, within the SK India institutions guidance and so on with the industry. So the green ones are the RF modules, which probably come to us as modules or PCBs. There'll be some kind of integration that will go on, while the machining of the feed on will be done in India and they will be assembled. There will be a lot of things that needs to be verified, and this is just a draft plan, and this needs to be vetted by much better experts in the field and then people who have uh, long-term experiences from the industry and institutions. So there's kind of different operational procedures involved in producing these feeds for the mid telescope. As we move on, the next work, which I have mentioned in the morning, is about the digital hardware. As you could see, these are hardware pieces which is made out of few thousand components and a few thousand of those boards to be produced, which essentially consist of a large number of surface mount devices and large FPGAs of huge capacities and so on. So that needs to be very carefully, not just board needs to be fabricated, but also to be assembled with such a precision that they don't wear out or they don't give up due to thermal expansions or any other reasons when the instrument is going to go through the thermal cycles and operating in a desert environment without any human intervention. They'll be switched on, switched off. They need to be so reliably working for not just few days. It should be 24 bar 7, 7 days a week, and all days of the month, and so on. They should come back on and off. So that's a very, very challenging task. Not just that, this FPGA being involved in the boards, there is a hardware component. Along with that, there is going to be this firmware component. So the board has to be tested. together, treating them as one package. It's the development process and the test process gets complicated because of that. And again, when we look at the SK low frequency telescope timeline, it's going to be 2024, 6 stations will be up, and it will be 3 times in the next year, and again 64 stations in 2026, and the entire telescope in operational in 2027, end of 2027. That looks like a long time, but however, many different components will have to be produced from different countries, and they'll all have to go to a place in Australia or somewhere where they will get assembled and tested, integrated, and before they are deployed. As you could see towards the end, the numbers are not just doubling, they are just 64 is becoming 256, is becoming 512 at the end. So things will have to be very well developed. Just to give a feel for what it means for this digital hardware, we have done a little more study, and I will show that in a moment. Like in the case of the feed, band 1 feed, even here there is going to be a early qualification of the PCBs. There's going to be a PCB regular production, which would involve few hours of inspection, thermal cycling, few hours of thermal cycling, production tests of different kind, and testing them to make sure there is no thermal related issues. It comes up, and there is no surprises when things are shut down for a while and when we want to bring them up. And similarly, there will be RF analog inputs. The 32 analog inputs gets into this board, and they need to be tested. Sometimes the boards, the components fail. When there are 3,000 components in a board and we have thousands of them, it's like a million components we are dealing with. Some of them can fail even if there is a 99.99%, there is going to be a failure, which is going to be very, very, very expensive if that failure happens in the field. It's very hard to get to that place and replace them. It's going to be costly effect. So what we usually do, taking our experiences from the previous work that we have done for the MWA and also other places, possibly people, industry will have much better experiences too. We do a test, leave the system on for 7 days, and usually a component that is likely to fail, most likely would fail in its early startup time. And if it doesn't fail, it will actually hold on for a long, long time until some really, really catastrophic thing happens. This has been our experience, and all that means there is a pipeline delay when a board comes out of PCB factory. When it comes out as fully tested, there's going to be a pipeline delay. So this means we need to really plan out when you want to make few thousands of these boards. So which is shown just for a feel for what the complexity involved in the next slide. So while the telescope is fully operational in 2027, we need to be finished with everything by 2024 or 2023, possibly 2024, making all the electronic components ready and available for field testing. So if you work backward, we need to probably begin our operation in 2021 first quarter, fourth quarter. The work involved 3 categories of aspects here. The first one that is circled here as 1, and the captioned as 1 is about industrialization. So boards need to be designed with certain manner that the industry can easily use them for automated assemblies, inspections, mounting them, and so many other aspects that can get missed out when a board is being designed. So that aspect will be perfected during the first phase. And again, this is just a plan, and based on the previous experiences that we have, and this will get revived again. And what is circled here as 2 is a pilot production. We don't end up producing 1,000 boards in one go. So we produce few boards and send them to the site. We do have some time available to get them tested with the feedback from the site. So pilot production. And 3A, 3B, 3C or overlapped production plan, which actually has been thought about as an overlap mainly because different phases of testing involves different kind of people's skills. So we would like to use as much as possible skilled people used in the same area as much as possible, so that we don't do an average performance everywhere, but we do good performance at every spot, which is a very tricky job, which is slightly different from how things happen in some other projects. We need to have people with certain skill sets available, and we don't want to lose them also. So it's a challenge. So the work is overlapped, which means the batch which will finish the first early part of the testing will come and start the early part in the second batch. People who are working on the later part of the production will come back and join here. So this needs to be properly timed. This is an indicated plan for an industry to do this job. This is assuming the SKA timelines we want to meet, and we also don't want to get this work tied up for a long time. There are a lot of challenges involved in this activity, especially component sourcing. Or earlier experiences of that the silicon vendors change their divisions, sometimes for reasonable reasons, sometimes just because the industry got sold to somebody else. So we don't want to get into a stage where the firmware and hardware compatibility is lost due to components not being sourced at the right time in right batches. There is also a risk if you source all of them together. There is also a possibility that we can lose many times. Some damages to the versions can cause very expensive errors, which means we end up losing the entire batch. So it needs to be balanced. So that's a challenge, how we want to do it. We also have to think about the spares, especially in the site like Western Australia, that can be lightning, that can damage large number of components in one stroke. So that needs to be thought about. And the cost of the components are already the major part in the design of in the tile processing module design. The batches, how do we manage the batches, and where do we store the components properly, so that also the finished products store them properly before they are dispatched. Storage, shipment, dealing with the batches is another challenge. The other major challenge is to plan about the test and automation for the automated tests for all these batches. Human intensive tests actually takes more time and they're error prone. Some of them can be automated, many of them can be automated. However, fine test cannot be automated. So a certain level of continuous quality control will be required. That's still a challenge in our work. And availability of the skilled personnel is another challenge. We have been looking into it, and we expect the industries to support us with very reasonably skilled people available for these activities. So this is the plan that we have for the digital boards, and a similar plan will be there for even for the other components. And this has been presented here just to give a feel for what it means. So I'm going to the next slide, where this is almost close to the end of my slides. And the idea here is to deliver things in such a way we not only meet with the antenna release plans of the SKA, but also meet with the other engineering tests that SKA will be planning. Around 2024, they would start the imaging test, pulsar timing by 2026. When sufficient collecting area is there, pulsar search would start. That would be 7 years down the line, 6.5, 7 years down the line. So this is the kind of plan that we need to meet, and it's little complex to balance both sides. Moving from here, we do have other areas of development and test for which I have not prepared any plans to project it here, but colleagues are thinking about it. One of them is related to the firmware feature development and related test. Another one is the TPM, the tile processing module advanced characterization, which would involve RF inputs, antenna, and also the firmware related tests, coupling with them, diagnostics, and so on. And then the last one is the PSS, which is related to setting up a HPC-based server class nodes to run and verify the search algorithms on our own sites. before the hardware actually is shipped to the sites. So we will be contributing in particularly the acceleration search, and we would like to verify them very well in our own ground before the things can be really deployed, which is really 7 years down the line. So that's one more area. And the last one is the band 1 feed related test. Still, it's not very clear. However, we would be doing some systematic tests with the band 1 feed, which would help us to characterize them before we actually deliver them to the SKA mid. So that's the end of my talk, and I'll stop here to take any questions.
Thank you, Prabhu. Are there questions for Prabhu right now? Please put up your hands if you have a question for Prabhu. Nirupam, is there anything on the YouTube?
I don't see anything. I don't see anything in the YouTube channel.
Okay. So shall we then move to the general discussion?